Welcome back. This is our next video in the series on examining relationships. We have so far examined what correlation is, what simple regression is. Now we're going to move into multiple regression. Multiple regression is employed when you want to examine the effects of many predictors simultaneously on an outcome variable. Simple regression is a basic form of regression with just one independent variable. In practice, it's more common to see multiple regression being used just because it's sort of like it's more practical. So the general form of the equation looks like this: y equal to b0 plus b1 x1 plus b2 x2 plus b3 x3, where x1, x2, x3 are n number of independent variables. And b1, b2, b3, so on are their respective regression coefficients, y being the dependent or outcome variable. Okay, so whenever you do multiple regression with more than one predictor or independent variable, you've got to think about a few other things. First things first, any interpretation of the effect of a variable is made under the assumption that everything else is being held constant. When you're looking at many predictors, we're also often interested in knowing which variable is the most important predictor. So relative importance becomes relevant or key here. When you look at many variables or many independent variables at one time, a concern is the presence of multicollinearity. Modest levels of multicollinearity are acceptable. In fact, it is almost realistic to expect some level of multicollinearity in your data. Multicollinearity occurs when your independent variables are correlated amongst themselves. It is when multicollinearity gets out of control. So if it gets to be above 5, let's say, we'd be concerned. That's a moderate to high level of multicollinearity. And if it's higher than 10, it represents serious multicollinearity. So long as multicollinearity is tamed, it's under control, if our variance inflating factor is under 5, we're usually okay with numbers being off of the ideal VI of 0. Okay, so what we're going to be doing here is examining the simultaneous effect of 3 independent variables. We've looked at 2 independent variables individually on sales. Now we'll look at the role of advertising, sales reps, and WEI all together influencing territory sales. So our HO here is that predictors do not influence sales. Predictors sales. That writing the R squared out was really painful, so I'm going to copy that from the previous slide. And that's the same as this. Now, here our predictors are, we don't have just one this time because we're running multiple regression. These are going to be advertising, sales reps, and WEI. And again, for so these jointly influence sales, and they jointly influence sales, right? So jointly is sort of like assumed, it just doesn't flow very well. Seems like poor grammar there, but the idea here is that we're looking at the joint influence of those 3 variables on sales. And then once we've examined the overall effect, we know that together these 3 predictors or independent variables affect sales. We can then peel the layers down and examine them individually through our regression variable hypotheses. So here you can start to write up hypotheses individually as something like this. So advertising, advertising does not influence sales, and then advertising influences sales. And we can do this for every individual variable of ours. We have 3, so that'd be reps. So this is, oh God, let me just do, sorry about that. Okay, here we have it set up now. You'd want to write a hypothesis for WEI also in the same kind of respect as for advertising and reps. Okay, let's run this now. Running this is very similar to what we had before, but we're gonna, in addition to running it like we did before, do a few other things. So these other things are as follows. We're gonna begin by examining here a multiple regression. I'll interpret the regression, and then we'll examine some other metrics for regression. So for now, I'm only going to run this part. We'll get to the second part, the last part in a little bit, okay? So go over to SPSS here and run the first part. Analyze regression linear. I'm going to, first things first, clear the screen. Move sales into dependent, and then we'll move all three of these to independence. Okay. Now, the next thing I'm going to do that's different from before, in addition to the fact that we're using three variables, is we're also going to check for the potential threat of multicollinearity by checking for collinearity diagnostics under statistics. Having done that, we can now examine our output. First things first, let's examine our overall R-squared. Overall R-squared is a whopping 0.881. It's pretty big. Okay, but let's not make qualitative judgments about R-squared. That R-squared should be examined using its statistical lens. Specifically here, our F statistic is 89, and our p-value is 0.00, is less than 0.001. In other words, let's head over to, back over to our slide. We have then found that our R-squared here is 0.881. F statistic is statistic. I'll get it right eventually, 89.051, and our p-value is less than 0.5. Okay. So what this tells us at this stage is that we have, we can reject a null hypothesis. In other words, advertising sales, sales reps and WI jointly influence sales, right? And the model is strong because our square is more than 0.5, okay? So we know the model is strong. Okay, there are a couple of other metrics for assessing how good the model is beyond just the R-squared. Those are RMSE and MAPE. I'll circle back to them in just a little bit after we're done interpreting the multiple regression equation. So let's go and now examine our individual hypotheses, which are right here. We have here in our coefficients table, you can see we have a we have here our unstandardized regression coefficients, which look like this. We have for each one of them a t-statistic, and we have a set of p-values. Let's examine them one by one. So as you look at these statistics, you can notice here for advertising, 12.968 is the coefficient. The t-statistic is 4.738, and importantly, the p-value is less than 0.05, and therefore significant. One should be fairly comfortable now rejecting the null hypothesis that advertising does not influence sales. Similarly, looking at number of sales reps, the B is 41.246 and the T 5.666. Importantly, p-value is less than 0.05, telling us then number of sales reps is also a significant predictor of sales. Let's go on to our last variable. Wholesale efficiency index, 11.524 is the B, and the t-statistic 1.498. However, our p-value is short of 0.05. Sorry, it's higher than 0.05. If this p-value were less than 0.05, we would comfortably conclude that wholesale efficiency index influences cells. Given how things are, the way they are here, one cannot say wholesale efficiency index influences cells. So what do we have individually? Let's go back to our slide. We can say out here for each one of these, the t statistic oops. So we have everything in here now. We're not skipping anything out. 4 points. T was 4.8. And the p-value is less than 0.05. Right? So, and then similarly here, we had 5.666, I think, was our. Everything's been sort of like significant for us so far, so it's good to have one that's not, right? So you can kind of see a situation where things don't pan out as hoped for. Our t-statistic here is 1.498, and our p-value comes up to be 0.143. That is not less than 0.05. You can then conclude, well, advertising influences cells. Reps influences cells. However, WI is not a significant influence in cells. That font became very small. Okay, so here's what we can say then, based on what we have, right? So. Right. Let's put it all together now in a regression equation, make sense of what we have so far. Our regression equation can be constructed using the measures in the regression coefficients column. I'm going to type them in here before going to the SPSS output window. So it's reading off the SPSS output window I have with me. It's 31.150 plus 12.968. Advertising and plus 41.246 times the reps. Okay, it's tempting for me to go ahead and add WEI also, and I'm not going to do that here just because it's probably not the right thing to do. Okay. And again, you're probably wondering, why don't you add WEI? Well, because we found out that the coefficient for WEI, whatever it is, was not significantly different from 0, meaning it is pretty much 0, and therefore 0 times WEI would have been then 0, and we should not, for that reason, include WEI in this regression equation. Let's go back to that output and see where all these numbers are coming from. So here is our table. So the numbers came from right here. I dropped WEI because, well, of this. It wasn't significant. Okay. Right. So that's our equation. Let's go back to our slide. So let's go back to the question then from before. What is the effect of adding 2 more sales reps? Okay, what is the effect on sales of adding 2 more sales reps, holding all other variables constant? This is important, right? We assume ceteris paribus. Then, when you examine the marginal effect of the coefficient of a variable in multiple regression, that is holding everything else constant. So, if you add 2 more sales reps, keeping advertising spots the same, you would then conclude sales would increase by 41.246 times 2, which would be whatever that number comes to. Do this math. The number is coming up 82.492. I'll plug that in here. units, right? That is, we know that is sales is in thousands of dollars. That's $82492. Okay. So that's the amount of the effect of adding 2 more sales reps, holding all of the variables constant now. I'm going to pause here for just a second, really short second. We've seen this one before. Effect of adding 2 more sales reps. We did this before. Let's scroll back a few slides to simple regression. There we found out the impact of adding 2 more sales reps was $132,000. Now we're finding out that number is $82,000. In other words, we're getting different regression coefficients, consequently different inferences of adding 2 more sales reps between the simple regression and multiple regression. This distance begs the question, which number should we trust? A multiple regression represents a more true picture of reality because reality is more complex than a simple regression. In most cases, if a regression is specified correctly, doesn't have specification bias, a multiple regression would be a better reflection of reality. And therefore, if you had to choose which one to trust, you trust the inference from multiple regression, not simple regression. Finally, this was a very busy table. There are a lot of things in this table that we didn't go over in entirety, and I'm going to do that right now. Now, 2 of them were, so 2 of them are, one is sort of like, you look at these different unstandardized coefficients. I'm not going to circle mark WEI because it's not even significant. So let's ignore that. Now, between advertising and number of sales reps, you look at those numbers, it's tempting to look at the coefficient of number of sales reps and conclude very quickly, number of sales reps is more impactful than advertising. But concluding that based on the unstandardized coefficients would be incorrect. Okay. Because unstandardized coefficients are just that, unstandardized. Keyword is unstandardized. When you compare coefficients in this unstandardized column, you may be comparing apples to oranges. We want to convert them all to apples. One way to do that would be to standardize them, to convert them to the same units. It's like you're comparing speed of 2 cars. One is measured in kilometers per hour, the other in miles per hour. They're not comparable. To make them comparable, you convert them to the same base, let's say miles per hour. Once you do that, they become comparable. That's what's happening in the standardized coefficients column. They're being made comparable by converting them to the same unit. Here you can note the standardized regression coefficient for number of sales reps is higher, and that is a good reason why it has a stronger influence on sales than does advertising. So we're gonna confirm this this sort of importance values based on the standardized regression coefficient. So strongest predictor of sales then is going to be number of sales reps, followed by advertising. And no need to mention WEI at all because it wasn't even a significant influence. All right, so what's missing now? A few more things. Let's go back to our table, and here we are. Let's examine what was missing. Oh, it's our VIF. The VIF is, sorry, the box here. Okay, the VIF. The VIF is a measure of multicollinearity. As I noted earlier, multicollinearity is something you see all the time. It's only when it's out of control that it's a concern or we kind of worry a lot about it. This is not something we'd want to worry about here. It's not high enough for us to be a threat or a serious concern. So we're gonna just kind of not worry about it in this case. Okay. Right. So this is a good time for me to take a breather, to pause. When I come back in the next video, I'm going to go over how to compute the RMSE and MAP metrics for their additional metrics for a multiple regression equation.